Alright, THS Chem Team, here's the next installment of your video links for at home. And this one's going to build upon what you've already started doing with your math involving heat and how much heat it is required to raise the temperature of a substance. These are going to be specifically designed to focus on just how much heat is required to go through a phase change or change between a solid, liquid, or a gas. So let's go ahead and get started. Alright, so this equation looks very similar to what we've already done, except for now we're not going to have specific heat involved. It's just going to be Q equals M, H, and then there'll be sub another letter here. And there's two that we're going to look at. One is going to have an HF, and one will have an HV. So that HF stands for heat of fusion, and it can also mean heat of crystallization. So there's some key words to look at here when we're talking about a problem. If we're talking about heat of fusion and heat of crystallization, you're going to see the key words in the question or the problem of melting or freezing. So if we see either of those two words in our problem, and it's talking about how much energy is required to melt or freeze something, that tells us we're going to use Q equals MHF as our equation. Whereas the key words, if we're going to be using the heat of vaporization, the key words there would be if we are boiling or condensing. So if our problem asks how much energy is it required to boil or condense a liquid, then we would know that we are going to be using Q equals MHV. The other clue to tell us that we're going to be using one of these two equations is that there will be no delta T involved. There's no change in temperature, because we are going through a phase change in the process. So that means our temperature is constant. So there's no change in temperature involved in either one of these equations. Alright, so let's take a look at a couple examples. Alright, so the first one, how much heat is required to raise the temperature of 30 grams of water from 20.4 to 32.0 degrees Celsius? And right away, we just talked about temperature staying constant. So I threw one of these in there just to get you to see that they're not going to specify which equation to use, so you're going to have to use the clues that are given to you. So if we see that we have a raise in temperature here, that tells us right away that we're not going to be using an HF or HV for one of our equations, but we're going to go back to using Q equals MC delta T. Okay, so from seeing that we're raising the temperature, we know we're going to have that change in temperature in there, so this is the only equation we have with that. So let's write out all the pieces that we know from the problem. Alright, so right away we have 30 grams, and we know that grams measures mass, so 30 grams for M. And we change from 20.4 to 32.0, so we're going to use that to get our delta T. So that's going to be 32.0 minus 20.4. And that gets us a change in temperature of 11.6 degrees Celsius. And I don't see any other values in there, but the other key that we do have is that we know that we're dealing with water. So if we know we're dealing with water, we're going to go to our reference table, and this is right on the first page of your reference table, and you'll see physical constants for water, and we need the specific heat, the C for water, and that is right here, 4.18 joules per gram Kelvin. So our C in this case is going to be 4.18. Okay, so now we have everything besides the one piece that we're missing, which in this case is it wants to know how much heat, and we know that if we're looking for heat, we're going to be looking for Q. So we're going to plug our values in and see what answer we get. So we have Q equals 30 grams times 4.18 joules per gram degrees Celsius times 11.6 degrees Celsius. So in this case, all we have to do is multiply all the way across. We are going to get some values to cancel out. And so since our unit for specific heat has grams on the bottom, that goes away. And it also has degrees Celsius or Kelvin, those go away. We're going to be left with a unit of joules, which is good because that is what heat is measured in. So when we multiply those all the way through, our final answer comes out to Q being 1455 joules. And if we're going to take care of our sig figs, we look at all of our measurements and we have 3 sig figs in all of our measurements. So this is actually going to be written out as 1460 joules. Alright, we're going to skip ahead to number 3. Okay, so number 3, I want you to circle the key terms here. We're looking for how much heat is required to melt ice, 85 grams of ice at 0 degrees Celsius. Now we do have a temperature in here, but we do not have a temperature change. We're staying at 0 degrees. We also see our key word here for melt. And we know that as soon as we see that key word for melt, that means we're going to be using the heat of fusion. So Q equals MHF. And again, we're dealing with water in this case. So that means we're going to get some values from our reference table. So let's get the values we can directly from the problem. First off, 85 grams. We see that G again, and we know that's our mass, is 85.0 grams. We're trying to look for heat, so we're looking for Q. So Q is our missing piece. And the other piece we need to get is HF. And that is always going to be based on your substance. That is a property of a specific substance. So again, you're going to have to go to your reference table. So looking at your reference table, right on the front page, where all those constants are for water, we're looking for heat of fusion, or HF, and it tells us that water has a heat of fusion of 334 joules per gram. So our HF for this problem is going to be 334 joules per gram. So these equations are actually a little bit easier because there's less to deal with. So we're going to plug in what we have here. We have Q equals 85 grams times 334 joules per gram. And so those are the only two numbers we have to throw in there. And again, let's look and see what units, if any, we can cancel out. And we can actually cancel out grams in this case, because in our unit for the heat of fusion, grams is on the bottom of our fraction. So it cancels out, and that'll leave us with joules as our unit of measurement, which is good because we're measuring heat, and that is an energy measured in joules. So again, in this case, all we're going to do is multiply across, and we get a Q value, or heat value, of 28,390 joules. And again, we still have to worry about sig figs. So the only measured value that we really have for our problem is 85.0, and that's 3 sig figs. So we're going to round our answer to 3 sig figs. And so our third sig fig is going to be cut off right there. So that's actually going to round up to 28,400 joules for your final answer for how much heat energy it would be required to melt 85 grams of ice. Alright, so we're going to do one more quick one. We're going to jump ahead to number 4. Alright, again, circle and underline the key terms here. What is the heat of vaporization of a substance A if it requires 75 joules of heat to boil 5.54 grams at its boiling point. So again, we see that we are boiling something. That tells us right away what equation we're going to use. We're going to use Q equals mHV. And the pieces that we're looking for the heat of vaporization. So our unknown in this case is actually our HV. So that means we should actually know our mass. Mass is 5.54. And our Q, which in this case is 752 joules. So plug these values into your equation, and you end up with a 752 joules equals 5.54 grams times HV. And we got to isolate our heat of vaporization to solve for it, so we're going to divide both sides by 5.54 grams. So we cancel out on this side. And HV, when we divide those two values, we end up with 135.7. And again, we're going to take our sig figs, and our sig figs are going to be at 3. So we're going to actually round this to 136. And then the units, you see, we didn't have anything cancel out in terms of units over here, so we're left with joules over grams or joules per gram. So again, remember to look for your keywords of boil, melt, freeze, and if the temperature is changing, to tell you which equation to use, and then get the rest of the information from the actual problem and your reference table. Finish numbers 2 and 5 for class to be checked tomorrow. Good luck.